Let us start discussing today's first problem. Question goes like this, that if pKa of log, that is pKa is equal to minus log of Ka is equal to 4, and Ka, that is the dissociation constant, is Cx square, then Van 't Hoff factor for weak monobasic acid we have to determine when C is equal to 0.01 molar is. 4 options are given. Options are, first option is options are 1.01, option B is 1.02, option C is 1.0, option D is 1.20. So we have to find out how it is done. Now while solving it, let us see in the question what are the things which are already given. pKa value is 4 which is given. So pKa, which is 4, which is minus log of Ka. At the same point of time, see, Ka is equal to Cx square, and it is said it is a monobasic acid. So monobasic means, obviously, suppose I have taken an acid which is Ha, which is H plus plus A minus. You can take any acid like that. So what happens is, suppose initially it is 1, it is 0 and 0, concentration I am talking about. Then after a certain point of time, it is suppose 1 minus alpha, and it is alpha and alpha, where alpha is dissociation constant. 1 minus alpha, alpha and alpha. If it is multiplied by any concentration, then it becomes like this. So now we know the dissociation constant of weak acids, Ka should be C alpha into C alpha divided by C into 1 minus alpha. So here C and C will cancel out. It forms C alpha squared divided by 1 minus alpha. And since alpha is very small, so 1 minus alpha is almost equal to 1. So it reduces to, the equation reduces to Ka is equal to C alpha square. You see the question, it is Cx square only. So we can consider alpha is equal to x in this particular case at least. Then what happens? We can write K is equal to Cx square. So x is basically nothing, it is dissociation constant. Now see on this equation, K is equal to C into x square. Ka, let us find out what would be the value of Ka. If 4 is equal to minus log Ka, if 4 is equal to minus log, which is 10 base Ka, then Ka should be 10 to the power minus 4. So the value of Ka is already determined. Now on this equation number 1 rather, the value of Ka, I am putting 10 to the power minus 4 is equal to C. Concentration in the question it is given 0.01. So it should be 0.01 into x square. So that is what we are able to calculate. So now if you calculate the value of x from here, it should be 0.1. So we have got the value of x. Now if alpha is equal to x, means the dissociation constant we are talking about, if we have to calculate the Van 't Hoff factor, let us rewrite. So initially if it is 1 and if it is 0 and if it is 0, means it is 1 molecule and it is 0 molecule and 0 molecule. After dissociation it becomes 1 minus x, and x as per the coefficient. Now number of particle after dissociation should be 1 minus x plus x plus x. that is 1 plus x. So the value of I, if we have to calculate, it will be the number of particles after dissociation, that is 1 plus x divided by 1. So that is nothing but 1 plus x itself. So I value is 1 plus x. X we have already calculated, so it should be 1 plus 0.1. So the answer is 1.1. So I value is 1.1. The second question for today is like this. Insulin, which is having the molecular formula C2H10O5 whole N, is dissolved in a suitable solvent, and the osmotic pressure, which is pi, of the solution is measured as at various concentration in kg per meter cube at 20 degrees Celsius. The slope of plot pi against C is found to be 8.134 into 10 to the power minus 3 in SI units. The molecular weight of the insulin in kg per mole is which one? The options are given. There is a small rectification. This 8.314 is actually misprinted in the question. It will be 8.314 into 10 to the power minus 3. So let us solve it. Since we know that as for osmotic pressure, pi is equal to CRT. And what is C? It is moles per liter. We can write pi by C is equal to RT by M. How can we write like that? Remember, this capital C is the concentration. Just to re-clarify, remember the capital C, which is in moles per liter, and the small c is kg per meter cube. So the value of capital C can be written as small c by capital M. This is molecular weight, and this is kg per meter cube. Remember here, C is equal to small c by capital M. That means the concentration in moles per liter can further be written as the concentration by molecular weight. This concentration is measured in kg per meter cube. So here pi is equal to C by M into RT. So this, if I take here, it becomes pi by C is equal to RT by M. Now M can be written as RT divided by pi by C, and it is also 8.314, the R value of R in SI, into value of T at 20 degrees Celsius. So it is 273 plus 20, which is 293, divided by pi by C. This value is already given in the question, which is 8.314 into 10 to the power minus 3. So 8.314 into 10 to the power minus 3. You calculate this, you will get the answer around 293 into 10 to the power 3, because this will go in the numerator. Next question for today is a different type of problem. Here the question is the ratio of delta TB by KB. Carefully see, we have not seen this type of problem yet. Delta TB by KB of 6% AB2 and 9% A2B is 1 mole per kg in both cases, while AB2 and A2B both are non-electrolytes. That means they are calculating delta TB by KB for 6% AB2 and 9% A2B, and they are getting it as 1 mole per kg in both the case. Question is, hence atomic masses of A and B are respectively, 4 options are given. Well, to solve this one, let us put the simple formula of delta TB. What it is? It is I into KB into M. Now, I, as the question suggests, it is a non-electrolyte. So, the value of I is said to be 1. So, there are two things. One is AB2, A2B. So, there are two cases. So, for the first case, if it is for AB2, let us calculate. So, delta TB is equal to KB. M can further be written as, we know, it is WB by MB into WA into 1000 if it is expressed in grams. And for case 2 also, if I calculate here, for A2B, it should be delta TB is equal to KB into WB means same thing, WB into 1000 divided by MB into WA. Now let us put the values. Here it is given 1 mole per kg. What? That is the ratio of delta TB by KB. So KB is here. Let us try to prepare the ratio delta TB by KB. Now it becomes WB by MB, or rather WB into 1000 divided by MB into WA. Now this much is how much? Is equal to 1. So it should be 1 is equal to, now WB, it is the number of moles of, weight of the solute, given mass of solute. According to the question, it is 6%. 6% means we can take WB as 6 and WA as 100. So that is what we are putting. 6 divided by MB into 1000 by 100. So this will cancel out. So it becomes 6 into 10 by MB. So MB is 60. For which one? For AB2. So that I am specifying. Similarly, here also it is delta TB by KB is equal to, since it's a 9% case, so WB should be 9 and WA should be 100. So here also KB we have taken here, WB by WA, that should be 9 to 1000 divided by MP into 100. So 9 by 100. Now same thing, it becomes 90 by MB is equal to 1. So the value of MB is equal to 90, which is equal to A to B. So these two we have calculated, the value of MB and MA in each cases. Now our job is to find out, according to the question, that the atomic masses. See, if we are supposed to calculate the atomic mass, then obviously the AB2, it will be dissociated into, so in AB2 we can write, it is the total molecule, there are 2 A atoms and 1 B atoms, and the total amount of this atomic weight is giving rise to 60. Similarly, for A to B, we are having, just a change here, in case of AB2, let us rewrite, in case of AB2, 1 plus, it is A plus 2B, which is equal to 60, because A atom is only once and there are 2 B atoms. So the combination of their atomic weight is actually 60. Similarly, for A to B, it is 2A plus B, and the value we are getting as 90. Now we should be able to solve this too. Let us solve. So in order to cancel it out, let us multiply suppose this is equation number A and this is equation number B. Let us multiply the equation number A by 2. So then it will be 2A plus 4B is equal to 120. And here also, if it is multiplied by 1, so it should be 2A plus B is equal to 90. So you subtract, it forms 3B is equal to 30. That means B is equal to 10. So putting the value of B is equal to 10 in any of these, suppose in the first case itself, A plus 2B, we are getting A plus 2 into 10 is equal to 60. That means A is equal to 40. So we are getting A is equal to 40 and B is equal to 10. That is the option number C. That is the correct one. Next question. Question is, an aqueous solution of a solute, A means just a solute, AB has boiling point of 101.08 degrees Celsius. Check it carefully. Solution, when it is formed, the boiling point is aqueous solution. That means from water the solution has formed and its boiling point is greater than 1. AB is 100% ionized at boiling point of the solution and freezes at minus 1.80 degree Celsius. Hence, AB is, 4 options are given, and Kb by Kf, that is molar boiling point elevation constant and freezing point depression constant, their ratio is 0.3. Very, very important information. You pause the video, write it down, write down the options also. Options are A, 100% ionized at freezing point of solution. Option B, behaves as non-electrolytes at the freezing point of the solution. Option C, forms dimer. Option D, none of the above. So let us solve it. So for that, I am writing down a simple formula, that is delta TB into I into Kb into M, that is equation number 1, and delta TF is equal to I into Kf into M. Here we have to find out out of these 4 options which one is correct. So see the options carefully. 100% ionized or not, it behaves as non-electrolytes or not, it forms dimer or not. So in all these cases we need to know basically the situation of I, and the questions belongs to the freezing point if you see carefully. So we have to calculate what is the value of IF, because IB is already given. Here you see AB is 100% ionized. In this line itself the value of IB is informed. That means at boiling point, if it is 100% ionized, that is AB, that is A plus plus B minus, so I value should be 2 by 1, which is 1. Which I value? It is IB actually. So it is IB and it is IF. In the question, Kb by Kf is also given. So if Kb by Kf is given, so 1 by 2 if I do, equation number 1 by 2, it forms delta Tb by delta Tf is equal to IB into Kb into M divided by IF into Kf into M. Let us see what are the values that are already known. Well, it is for the same solution, so this will cancel each other out. Kb by Kf, the value is already given, 0.3. So I can write, and value of IB is also, it should be 2 rather. So it is 2 into 0.3 divided by IF. And on the left hand side, delta TB, the value is given as, it is the delta TB means the elevation in boiling point. So the value should be 101.08 minus 100 degrees Celsius. That means it is 1.08 degrees Celsius. So here I can write 1.08 and delta TF is given minus 1.80. So it is 1.80. So now we should calculate the value of IF from here. So IF should be 1.08. Sorry, it should be 2 into 0.3 into 1.80 divided by 1.08. Calculate the value. After calculation, we will be getting the value of IF is equal to 1. The value of IF is equal to 1 means before the dissociation and after the dissociation, the number of particles remains the same. So, is it 100% ionized? No. Behaves as non-electrolytes? Yes, because if it is non-electrolyte at the freezing point, then only the value of IF can be is equal to 1. So this is the correct answer.